Okay, so today we're talking about angles and radian measure. So before, when we talked about an angle, we were usually talking about part of a triangle. Now we're going to talk about angles as a vertex, which is a point where we're going to call them two rays meet. So our vertex would be like right here, and then we have our initial ray, and then we have a terminal ray.
Okay.
So what an angle is now is it's a rotation around this vertex. So our initial ray is where we start, our terminal ray is where we end. So for our first one, we're rotating 40 degrees. So we start at our initial and we rotate 40 degrees. So this is our 40 degrees. Yes?
Is the initial always facing to the right, or is it just like if it hits one of the four parts equally? Like if it was a vertical line and then one was going out to the 45, would the vertical be
Yeah,
the initial?
your initial can be anywhere.
Okay.
We'll talk about it in a little while, but if it's said to be in standard position, your initial ray will be on the positive x-axis. So that would be in this position.
Yeah.
Would be on your positive x-axis, and that's standard position. But your initial ray can be anywhere.
I remember this.
In this case.
How many times you have to rotate for it to be like 830?
Negative is this way.
So our second example is 830 degrees. So 830 degrees, we know that a circle is 360, so if we started at our initial ray
Yeah.
and went around once,
Twice.
that's 360. And then if we go around again,
That's 720.
we're adding 360 again, so we're at 720.
I go another 110 degrees.
So then we have to go another 110 degrees. Now how'd you get that 110 degrees?
Because you're at 720, you need to get 830.
We took the 830 minus the 720, and you get your extra 110 degrees. So that's the rest of the way there.
Bam.
So that will give you your 830 degree angle. Our next example is a negative. So we have negative 43 degrees. So when we have a negative, we've got our initial ray, and we're going to rotate backwards or clockwise. So for positives, we're going counterclockwise. For negatives, we're going clockwise. So this is our negative 43 degree angle. So then our last example here is a negative 312 degree angle. So we'll start at our initial, rotate around, this would be 90, 180, 270, and then that little extra for 315, or 312. So that would be our negative 312 degree angle. So like Nick was asking about, if we could have the initial ray anywhere.
Yeah.
So this is talking about the standard position here. Standard position is your initial ray is on the positive x-axis in the coordinate plane.
Okay.
So again, positive angles go counterclockwise. And negative go clockwise. So now we're going to talk about something called coterminal angles. Now coterminal angles are angles that are formed by different rotations but have the same initial and terminal sides. So they give the example of 0 degrees and 360 degrees are coterminal. Because if we look at our coordinate plane, 0 degrees, we would start here and we don't go anywhere because it's 0 degrees. So we start and end there. 360, we do a full circle, so we started here and we ended here. So that's why they're coterminal. So there's a note on the bottom that says increasing or decreasing the angle measured by adding or subtracting any multiple of 360 will result in a coterminal angle. So that's important for our first example, which asks us to find 3 angles that are coterminal with the angle 60 degrees in standard position.
So just add them.
So our 60 degree in standard position, our 60 degree angle would be here. So we need to find 3 angles that are coterminal with that 60 degrees.
360 minus, or 60 minus 360.
So we could do
So
60
negative 300.
minus
And 420.
360. So that's going to give us a negative 300 degree angle. That would be a coterminal angle. What else could we do?
420.
So that's 60 plus 360 would give us the 420. That's a coterminal angle. And we need a third one. So what else could we do?
720 or minus.
So you want to add another 360. So that would give you
780.
780. And that is also a coterminal angle. So you can either subtract 360, multiples of 360, or add multiples of 360. So those are 3 good coterminal angles. The next picture is just showing you the coordinate plane and how you can break it up so that it's a little easier to find some of these angles. So normally with just the x and y axis, you would have it divided up by 90. If you split each of the 90 degrees, then you have your 45 degree angles or multiples. And then you can also divide it by 30s. So you would have your 30 degree, your 60 degree, and so on. So that makes it slightly easier to find some of these angles. So now we're going to get into radian measure. Now radian measure is like when we were switching our calculators from radian mode to degree mode so that we could find the trig ratios the other day. This is what radian means. Radian is used more in calculus and physics. It makes finding certain rotations or for certain applications, it makes it easier to find those in calculus and physics, so that's when radian is usually used. So we're going to learn how to convert from degrees to radian and from radian to degrees. And this here is our conversion. It says that 1 radian equals 180 over pi degrees, which is approximately 57.3 degrees. And this unit circle gives us some of the more common radian degrees or radian measures for specific degrees. You don't have to memorize these, but they are good to know because they are some of the most common ones. that we'll use. And if you know the degree or the radian, you can always convert back so that you don't have to memorize this.
Are you going to give it to us on times we'll get it printed?
This circle.
Are we need to have pictures, know that?
You need to know how to convert back and forth, but you're not going to have to memorize all of these. If you know how to convert back and forth, you can find any of these.
Okay.
So that's what we're going to do next. So converting between degrees and radians. So we have a few conversions that we know. So pi radians equals 180 degrees. 1 radian, like we said before, equals 180 over pi degrees. And pi over 80 radians equals 1 degree.
So you multiply by x and then divide by.
So,
7.3.
so to convert radians to degrees, we're going to multiply by 180 over pi. And to convert from degrees to radians, we're going to multiply by pi over 180. So example 3 is converting from radians to degrees. So what do we multiply by to convert from radians to degrees?
180 over pi.
So we're going to multiply by 180 over pi.
So the pi's are going to cancel.
The pi's are going to cancel out,
And then you could take out 5
and you can take out a 5,
from that.
and 5 goes into 180
36 times.
36 times. So you end up getting
36.
a 36-degree angle. And for B, again, we're going to multiply by 180 over pi.
Divide both by 9 and cancel the pi.
The pi's cancel. Divide by 9.
So 1 and then 20,
So we have 4 times 20.
80.
So you get an 80-degree angle.
And the next one is about 6 pi over 1 multiplied by 180 over pi.
So again, we're multiplying by 180 over pi. Your pi's cancel out. You get 6 times 180,
840. Right.
1080.
Oh, just kidding, I'm stupid. 6 times 80. I didn't multiply that. I did 6 times 40.
And then example 4. Now we're converting from degrees to radians. So what are we multiplying by to convert from degrees
Pi
to
over
radians?
180.
So now we're multiplying by pi over 180. So when we multiply through, we can simplify this
By 5.
by 5 and
That doesn't come out to 5 on top though.
we're not dividing by 5, sorry.
Oh.
We're dividing by what am I dividing
15.
by? Yeah.
Yeah,
Dividing
yeah,
by 15.
Okay.
Yeah. So you're gonna get
5
5 pi over 12 is your radian measurement now. So 220, again, we're multiplying by pi over 180. And when you reduce it, you should get 11 pi over 9. And C. Again, time multiplied by pi over 180.
Oh,
Appreciate the blessing.
And once you reduce, you should get 20 pi over 9. So those are the conversions between degrees and radians. So now, if we talked about coterminal angles for degrees, So now we're going to talk about coterminal angles using radian measure. So it says increasing or decreasing the radian measure of an angle by an integer multiple of 2 pi results in a coterminal angle. Which makes sense because 360 equals 2 pi. So this is just using it in radian form. So example 5 says find one positive and one negative coterminal angle to negative pi over 3. So how can we find the positive coterminal angle for this?
So 2 pi.
So we have negative pi over 3. What can we do to find a positive coterminal angle?
Can you add 2?
So we're going to add 2 pi. So now, like adding a fraction and a whole number, we have to get a common denominator.
So 6 pi over 3.
So we're going to multiply by 3 on the top and the bottom.
So 5 pi.
We'll have negative pi over 3 plus 6 pi over 3.
5 pi.
And you end up with 5 pi over 3. So that's our positive coterminal angle. Now we need to find a negative coterminal
So I'll
angle.
subtract 2 pi.
So now we're going to subtract 2 pi.
So it's what, minus 7 pi over
So again, getting your common denominator. And you end up with negative 7 pi over 3. And our last example. It wants you to state the radian measure of an angle between 0 and 2 pi that is coterminal to negative 3 pi over 4. So this wants an angle
Positive.
of radian measure that is positive. So right now you have a negative, so what are we going to do to find a positive radian measure? Do we need to add 4 pi? It has to be between 0 and 2 pi, so it needs to be within that first rotation. So we're going to just add 2 pi. So we have 3 pi over 4 plus 2 pi. And again, we have to get a common denominator. So we're going to have negative 3 pi over 4 plus 8 pi over 4. And we get 5 pi over 4. And that is between 0 and 2 pi. Because if we look at it on the coordinate plane, our negative 3 pi over 4 would be over here. This negative, or this positive 5 pi over 4 gives us the positive angle. So this is the negative 3 pi over 4. This is the 5 pi over 4. And that is all we are covering today. The last page is your homework, the front and the back. And we're done.